Hey guys, what is up? Today we will be rationalizing denominators, or in other words, we're going to be simplifying fractions with radicals. Okay, so go ahead and copy that down and we'll get started. All right, so the first thing we need to do is just kind of get warmed up on simplifying radicals, okay? You haven't done it in a long time, but let me get you started here. Simplify radicals, and then this is review, okay? So we'll start off with this example, the square root of 180, okay? All right, now if you remember, to simplify this, we have to start off with perfect squares, okay? Numbers that are perfect squares, okay? So I don't know if you remember or not, but we would start off with our list of perfect squares, okay? And that list would be something like this. One of our perfect squares is 1, because that's 1 squared. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 36. 49. 64. 9 squared is 81. 10 squared is 100. 11 squared is 121, 12 squared is 144, 13 squared is 169, and so on. Okay? And the thing is, remember, we were trying to find a perfect square that was hiding in here. Okay? So one of these numbers is going to be hiding in here if we're going to simplify it. And remember what we did? We started with our biggest number first. So 180 divided by 169. Does that go into it evenly? Okay? If it doesn't, then try 144. Does that go into 180 evenly? Okay. Does 121 go into 180 evenly? Okay. So that's what we're trying to do, is figure out which number goes into 180 evenly. Okay. And that is something we did at the start of the year. I'm not expecting you guys to be perfect at it right now, but let me just show you one easy way to do this. All right. When I see the number 18, notice there's an 18 there. I know this is 18 times 10, right? Okay, but when I see the number 18, I know 9 goes into 18, and I know 9 is on my list right here. 9 is right there, okay? So I know that if I divide 180 by 9, okay, I get 20. Okay, so watch this. I'm going to replace this with 2 radicals. Okay, again, this should just be review. Okay, and that's 9 times 20. Okay, and this is great. I've got a perfect square. That's awesome. Now look at the 20. Is there a perfect square hiding in the 20? All right, remember, here's our perfect squares, okay? Is 20 divisible by 9? Nope. Is 20 divisible by 4? It sure is, so watch this. Now I'm going to recopy this, so it's 9, the square root of 9, and then 2 square roots for the 20. And what 2 numbers multiply to make 20? 4 times 5. Now I know I can use 2 times 10, but 2 is not a perfect square and neither is 10. Okay, 4 is a perfect square. The reason I want perfect squares is because now watch this. What's the square root of 9? It's 3. What's the square root of 4? It's 2. And the square root of 5 can't be reduced. So now we have 3 times 2 times square root of 5. 3 times 2 is 6 times the square root of 5, and that is how we simplify the square root of 180. Okay, you try one really quick. How about the square root of 72? All right, pause the video, give it a shot. All right, here we go. I know that I can break up the square root of 72 into 2 numbers, okay? I know that 72 is divisible by 9. 9 is a perfect square, so I'm going to put 9, and it's 9 times 8, okay? Now let's look at that 8. Is there a perfect square hiding in the 8? Yeah, there's a 4 hiding in the 8. So watch this. Rewrite the 9, square root of 9, and then 2 square roots for the 8, for the square root of 8, okay? 4 times 2. Square root of 4 times square root of 2 equals square root of 8. And now look, perfect square, perfect square. So this is 3, this is 2, and this stays square root of 2, and we get 3 times 2 is 6, square root of 2. Okay, so that is just review. All right, now let me throw something else at you, okay? I'm going to show you this. Rationalizing rationalize the denominator. Okay, so here we go. I'm going to rationalize the denominator. Here's my example. This is 2 over the square root of 5. Okay? What do I mean when I say rationalize the denominator? Okay, well, I mean we're going to simplify the fraction that has a radical in it. Okay, rationalizing denominators means we're simplifying fractions with radicals. This is a fraction. It has a radical in it. How do you simplify it? So basically, to rationalize the denominator, it means we do not want a radical in the denominator anymore. Okay, so there's one very easy way to deal with this. Whatever you have as your denominator, if you multiply, here, let me do it this way. I'm going to copy this again so you can see my steps. 2 over the square root of 5, okay? I'm going to multiply by 1. But watch how I write 1. I'm going to write 1 as the square root of 5 divided by the square root of 5. Isn't the square root of 5 divided by the square root of 5, isn't that 1? Okay, so I'm really multiplying this by 1. But watch what happens. Multiply the numerator. 2 times the square root of 5. What do you get? You get 2 times the square root of 5. Now, that was tough, okay? Divided by, well, what's the square root of 5 times the square root of 5? That's the square root of 25. What's the square root of 25? It's 5. So the square root of 5 times the square root of 5 is just 5. Watch this. What's the square root of 31 times the square root of 31? Any guesses? You got it. It's 31. Okay? So that's how it works. And now take a look. I have 2 times the square root of 5 divided by 5. Do I have a radical in the denominator anymore? No. So guess what I've just done? I've rationalized the denominator. Here, you try one. How about 3 divided by the square root of 10? Okay, here we go. Multiply by the square root of, multiply by 1. So the square root of 10 over the square root of 10, right? Okay, whatever the radical is in the denominator, that's what you're going to use to make 1. All right, 3 times square root of 10 is 3 square root 10. Divided by square root of 10 times square root of 10, well, that's square root of 100. Square root of 100 is 10. Okay, square root of 10 times square root of 10 is just 10. Remember how we did this? Square root of 31 times square root of 31 is 31. Same thing. Whatever your square roots are, that's what you get without the square root. Okay? All right, let's do one that's a little more complicated. Ready? Here we go. Example. How about 6 divided by the square root of 3? All right, so watch this. I need to rationalize the denominator. There's a radical in the denominator that I do not want, so I'm going to multiply by 1. All right, square root of 3 over square root of 3. That's 1. All right, now watch this. 6 times square root of 3. 6 times square root of 3 divided by square root of 3 times square root of 3. Quick, what is it? Good, it's 3. All right, but now look. Notice there's a 6 in the numerator and a 3 in the denominator. Do you notice what they have in common? That's right, they are both divisible by 3. So 6 divided by 3 is 2. 3 divided by 3 is 1. And look what I get. I get 2 radical 3 divided by 1. Or just 2 radical 3. Okay, here, you try one. All right, how about 8 divided by the square root of 6? All right, pause the video. All right, here we go. Multiply by square root of 6 over square root of 6. 8 square root of 6 divided by square root of 6 times square root of 6 is just 6. All right, what does 8 and 6 have in common? They're both divisible by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. My simplified fraction is 4 square root 6 divided by 3. All right. Now let's bump it up one more notch. Here we go. I'm going to make this a little more challenging. 7 divided by the square root of 27. Okay? How do we do this? Well, all right. First things first. We have a square root of 27. Okay? Let's rationalize that. Here we go. Multiply by square root of 27. Square root of 27. What do you get? Okay? Here we go. 7 square root 27 over 27. All right, so far, not too bad. But here's the thing, the square root of 27, okay, that can be broken down. All right, so let's just off to the side, here we go. Okay, square root of 27. Do you see a perfect square hiding in there? That's right, I do. What two numbers multiply to make 27? 9 times 3. So the square root of 9 times the square root of 3 is the square root of 27. That's a perfect square. So guess what I get? I get 3 square root 3. So that's what I'm going to replace right there. I'm going to replace that square root of 27 with 3 square root 3. So watch what I get. I get 7 times 3, so 7 times 3 times the square root of 3 divided by 27. Okay. Now do you see any numbers here that have anything in common? Isn't 27 divisible by 3? 3 divided by 3 is 1. 27 divided by 3 is 9. So my final answer is 7 times 1 is 7 times radical 3 divided by 9. So there's my final answer there. Okay, let's do one more here. One more example. Let me just get this out of the way here. All right, you guys try this. Try this guy. Example. 3 divided by the square root of 45. Okay, see what happens. All right, you ready? Did you pause the video? Did you try it on your own? Okay, here we go. I'm going to multiply square root of 45 divided by square root of 45. Okay, and I get 3 square root of 45 divided by 45. Okay. Now there are a few simplifications here, okay? First off, the square root of 45. Let's do this off on the side, ready? Square root of 45, okay? Can I break that up into 2 radicals? What times what gives me 45? That's right, it's 9 times 5. That gives me 45. Oh my gosh, my pencil just broke in half. Let's see if I can find another pencil. Here we go. That was odd. All right, and here's my perfect square. So this is 3 square root of 5. So that right there is what I'm going to replace that guy with. Okay, so I get 3 times another 3 times the square root of 5 divided by 45. All right, now look, 3 times 3, that's 9. So I have 9 square root of 5 divided by 45. Okay, and do you notice what a 9 and a 45 has in common? Yeah, they are both divisible by 9. So 9 divided by 9 is 1. 45 divided by 9 is 5. And I get 1 times radical 5. That's radical 5 divided by 5. And that's that. All right, guys, if you need any more help, let me know. I'm here. Peace.